Hey, sunshines! So it's time to learn about rotational symmetry. So, rotational symmetry is when a figure rotates and maps onto itself. So, it rotates around and it lines up with itself. So, for example, this equilateral triangle here, if I rotate it, I have an identical one behind it. If I rotate it, now it's not quite rotating the way Jamboard works. It's not grabbing the center of the triangle, it's grabbing the center of the square, which is a little off. So it's not lining up correctly until I move it. But if I rotate it, I can line up my original top point is now matching one of my base points. And I could rotate it again and it'll line up. Not quite perfect, but. And then if I rotate it all the way around back to where I started, so there were three positions I could put that triangle in where it mapped onto itself. So how many degrees did I have to turn it? So if there were three positions, so I have my top point here, that's position one, position two, and position three. So a full circle is 360 degrees. And then you just divide by how many positions you have to get that degrees. So if my center is here, then I'm rotating it so that I go from there, that's not quite the center, to there. And so this angle, 360 divided by 3 is 120. So this angle is 120 degrees. So if I rotate it 120 degrees, I get from position 1 to position 2. And all multiples of that are also going to be degrees of rotation. We usually focus on the smallest degree of rotation, but all of the multiples are also correct. So 240, and then 360 is the identity rotation. We don't really talk about that because it doesn't count if it's